Welcome to class 10 science chapter 4 carbon and its compounds. In this video we are going to discuss about functional groups and homologous series. First come to the functional groups. In a hydrocarbon chain, one or more hydrogens can be replaced by the other elements such as halogens, oxygen, nitrogen and sulfur such that the valency of carbon remains satisfied. Now where this is halogens means either chlorine, bromine, iodine, fluorines, these are known as halogens. In such compounds, the element replacing hydrogen is referred to as heteroatom. We can say like halogens, oxygen, nitrogen, sulfur which are present in the carbon compounds by obtaining or by replacing hydrogen. These atoms are known as heteroatoms. These heteroatoms are also present in some groups. These heteroatoms and the group containing these confer specific properties to the compound regardless of the length and nature of the carbon chain and hence are called functional groups. We can also say atoms or group of atoms which impart specific properties to the organic compounds are called functional groups. The functional group is an atom or group of atoms joined to the carbon chain which is responsible for the characteristic chemical properties of the organic compounds. For example, hydroxyl group, that is OH, aldehyde group CHO, carboxylic acid group COOH, etc. Now see, in 10th class we will discuss about these functional groups. If heteroatom may be Cl and Br, that is this is chlorine and this is bromine. If these heteroatoms present in a chain of carbon compounds, then these are known as in general halo. From halogens we can write halo. For specific, chlorine is written as a chloro and bromine is written as a bromo. So we can say this is a haloalkane. Clear? And hydrogen atom is replaced by Cl or Br. If heteroatom is oxygen, then this oxygen is present in different class of compounds. Okay, alcohol OH, aldehyde CHO, ketone CO, carboxylic acid COOH. Now we will discuss one by one. First come to the alcohol. Functional group is OH. That is hydrogen atom of alkane is replaced by OH group. How can we write its name? E of the parent alkane is replaced by OL. That's why we can say this is alkanol. For example, methane. If we replace its one hydrogen atom by OH, then we will get CH3OH. Its IUPAC name is methanol. In common system, this is known as methyl alcohol. This group is called methyl. Okay, this is its structure and this is its electron dot structure. Clear? Now if come to the second member, then this is C2H6 ethane. The C2H6 may also be written as CH3CH3. If one of the hydrogen atom is replaced by OH, then we will get C2H5OH. This may also be written as CH3CH2OH and its IUPAC name is ethanol because it is obtained from, or we can say it has two carbon atoms and these are linked by a single bond and functional group is OH. That's why this is ethanol. In common system, this is known as ethyl alcohol. This group C2H5H, C2H5, this is called ethyl. Now I think you have understood, that is if this represent RH as alkane and if one hydrogen atom of this alkane is replaced, then we'll get R. So if this is alkane, okay, alkane, then if we remove its one hydrogen atom, then we will get this is alkyl. ALKYL. From methane, methyl. From ethane, ethyl. Clear? This is its structural formula of ethyl alcohol CH3CH2OH, and this is its electron dot structure. Clear, student? Now next is aldehyde. Functional group is CHO, but again remember, H is not directly bonded to the oxygen. Actually, bonding in CHO is like this. Oxygen is double bonded with this carbon, and hydrogen is also double bonded with this carbon. Now this dash represent that its one valency is free. Okay. Now this free valency if may be satisfied by hydrogen atom, or it may be satisfied by alkyl group. Okay. IUPAC name. Parent alkane is replaced by Al, that is E of the parent alkane. E of the parent alkane is replaced by Al, then we will get this alkanal. First member. How can we get the first member of aldehyde series? As we discussed, that CHO is the functional group, and the free valency of this carbon, if satisfied by hydrogen, then we will get its first member, and that is HCHO, methanol. In common system, this is known as formaldehyde, and this methanol, its structural formula can be represented either like this or this. You can write like this or this. Clear? Second member. If the free valency of CHO is satisfied by the simplest alkyl group, that is methyl, then we will get this, its second member, CH3CHO. Now in this case, there are the two carbon atoms. Total number of carbon atoms are 2. That's why its name is ethanol. Okay. This eth for 2 carbon atoms, An bonded with the single bond, that's why An, and E of the alkane is replaced by Al. This is for aldehyde group, ethanol. This is its structural formula, and this is its electron dot structure, CH3CHO. Okay. Actually, there is CO group, that is known as carbonyl group. Its 2 valencies are free. Okay. If out of these 2 valency, one valency is always satisfied by hydrogen, then we will get aldehyde. And its second valency may be satisfied either by hydrogen or by alkyl group. Okay. But if both the free valency of this carbonyl carbon is satisfied by the alkyl group, then we will get ketone. Okay, so we can say the functional group of ketone is this CO. This may also be written like this is CO or CO. And these both the valencies, free valency of this carbon, are always satisfied by the alkyl groups. These alkyl groups may be same or may be different. That's why we can say this is R and R dash. They may be same or they may be different. Then how can we write name? Then we can say E of the parent alkane is replaced by ONE. Then we will get this alkanone. What we call it? Alkanone. Then what is the formula of its first member of ketone series? Clear? Now again remember, its first member contains 3 carbon atoms. Clear? Minimum number of carbon atoms present in the first member of ketone is 3. Clear? And its formula is CH3COCH3. And there are the 3 carbon atoms, 1, 2 and 3. That's why this is called propanone. In common system, this is also known as acetone. Actually, this acetone is the one constituent of nail polish remover. Clear? And this propanone can be written like this. This is the complete structural formula of propanone. CH3COCH3. Don't be confused. In this way, we can say this oxygen is not bonded with this carbon not bonded with this carbon. This oxygen is bonded with this middle carbon with the double bond like this. Okay, and this is its electron dot structure. Now next member. Now we are saying that free valency of this carbon is satisfied by the alkyl group. If both side simplest alkyl group methyl is added, we will get the propanol. But if one side, if we add the next alkyl group, that is ethyl, then we will get its second member. This ethyl may be added to left hand side or it may be added to the right hand side. Both represent the same compound and its name is butanol. And this is its structure: CH3, CH2, CO, CH3. Yeah. Next one is carboxylic acid. Functional group is COOH. Again, remember, both oxygen are not directly bonded to each other. Actually, this is the bonding in COOH. One of the oxygen atom is double bonded with the carbon, and this OH is attached single bond with this carbon and single bond with this hydrogen. And free valency of this COOH group is satisfied by hydrogen atom or by alkyl group. Okay, and how can we write its name? That is, E of the parent alkane is replaced by oic acid, then we will get alkanoic acid. Okay, now if H is satisfied, if H satisfied this free valency, then we will get its first member HCOOH. And in this case, there is one carbon atom is present. That's why its name is methanoic acid. In the common system, this is known as formic acid. And structure can be represented like this. This is the methanoic acid. Second member, if the free valency of COOH group is satisfied by the simplest alkyl group, that is methyl, you will get this CH3COOH. And in this case, two carbon atoms are present. That's why its name is ethanoic acid. Commonly, this is known as acetic acid. I think you are familiar with this term, acetic acid, vinegar. Acetic acid, this is acetic acid is present in vinegar. And this is the structure of CH3COOH, and you can also make structure like this, CH3COOH. This is the electron dot structure of CH3COOH, ethanoic acid or acetic acid. Haloalkanes. Now in this case, functional group is X halogens, and halogens are fluorine, chlorine, bromine, iodine. These are known as halogens, and commonly they are represented by X. Means hydrogen atom of alkane is replaced by halogen, then we will get the haloalkanes. And this halo is written as prefix in IUPAC name. Okay, prefix to alkane. That's why this is haloalkane. And fluorine, this is element, but if it is written in the form of prefix, we will write as a fluoro. Cl will be written as chloro. Br will be written as bromo. I will be written as iodine. For example, if one of the hydrogen atom is replaced, one of the hydrogen atom of methane is replaced by Cl, then we will get CH3Cl. This is called chloromethane, and this is its structure. In case of ethane, if one of the hydrogen atom is replaced by chlorine, then we will get this structure CH3CH2Cl, and this is called chloroethane, and this is the structure. Now this Cl may be written at any place. Okay, this Cl you can write with at this place or at this place, at any place. In the same way, if Br replacing one of the hydrogen atom, then we will get the CH3CH2Br, that is bromoethane. This is the structure of bromoethane. Like in this case, Br we added to this position. You can also add Br to this position. Then in that case, this H will go to this position. Okay, so this is haloalkanes. Homologous series. Dear student, we have discussed about alkane, alkene, alkyne, alcohol, aldehyde, ketone and carboxylic acid. And see, alkane, this is the general formula CnH2n plus 2, and if we put the value of n like 1, 2, 3, we will get this is CH4, C2H6, C3H8. In the same way, alkene CnH2n, if we put the value of N2, then we will get N is equal to 2, then C2H4, C3H6, C4H8. The same way, CnH2n minus 2. This is the general formula of alkyne. If we put the value 2 of alkane N, okay, if N is equal to 2, then we will get C2H2, C3H6, C4H6. Now just observe, when you go from this to this, what is the change in this formula? You can say that is, this is changing by like this. If this is the difference between CH4 and C2H6, CH2. In the same way, if you go from this to this, again difference is of CH2. In the same way, if you go from this to this, what is the difference in the formula? This is again CH2. Okay, and again if you go from this to this, the difference is again CH2. In the same way, if you go from this to this and this to this, the difference is CH2. Is it clear? In the same way, alcohol, this is its general formula, CnH2n plus 1 OH. Actually, this represents the alkyl group. Okay, if N is equal to 1, we will get CH3OH. If N is equal to 2, we will get C2H5OH. In the same way, C3H7. Again, you see the change in the formula. If you go from this to this, the change one is, this is again CH2. And from this to this, the change is again, this is CH2. Now, this is the general formula of aldehyde. Functional group of aldehyde is CHO, and this again represents the alkyl group. Okay. If N is equal to 0, then we will get this formula. Okay, if N is equal to 1, this. N is equal to 2, we will get this one. Again, if you see from this to this and this to this, the change in the formula is, that is CH2. In the same way, this is ketone, carbonyl group CO. On both the side, alkyl group is added, that is CnH2n plus 1, and this side also CnH2n plus 1. Simplest methyl group, simplest alkyl group is CH3. That's why this is first member, this is second member, this is third member. If you see the change from this to this and this to this, again change is equal to that, this CH2. Carboxylic acid, functional group is COOH, and this is the alkyl group, general formula of alkyl group. If N is equal to 0, then we will get this formula. If N is equal to 1, we will get this one. If N is equal to 2, we will get this one. If you see the difference from this to this and this to this, again difference is CH2. Clear? Now, a group or a series of organic compounds, each containing a characteristic functional group, forms a homologous series, and the member of the series are called homologous. Is it clear? So we can say this alkane, this complete series, alkane homologous series, or simply alkane series, alkene series, alkyne series, alcohol series, aldehyde series, ketone series, and carboxylic acid series. Clear? Now, what are the characteristics of this homologous series? Formulae of successive compounds of a series differ by CH2 unit. Clear? And successive members of a series differ by 12 U in their molecular mass, because this molecular mass of this group or mass of this group is 12. Sorry, wrong. It will be 40, not 12. This will be 40. Make it 40. Okay, because carbon is 12 and 2 atoms of hydrogen, and atomic mass of hydrogen is 1. That's why this will be equal to 40. Successive members of series differ by 14 in their molecular mass, and all members of series can be represented by a general formula we have already discussed. All members have the same chemical properties, because chemical properties decided by the functional group, and all members have the same functional group. There is a gradation in physical properties on increasing molecular mass. Now, in physical properties like melting point, boiling point, okay, if the number of carbon atoms increases, then melting point and boiling point will also increase. And all members can be prepared by the general methods of preparation. So, these are the some characteristics of homologous series. Okay, student, subscribe my channel if not yet. Thank you.